So this is an example of where things get messy. In putting cards together out of parts from various things, things don't always match up and line up, and it gets expensive. And I got the engine back together, new camshaft, lifters, valve springs, reassembled, new gaskets, and everything's going along fine. When I got to the vibration damper, I was wanting to make a change anyway. The one that came with this engine is used in trucks and vans. It's very deep. It has a very deep distance from the crank to the front of the pulleys, because in pickup trucks and vans they got a lot of room, and so they move all of the V-drive further out. This interferes very much with my radiator support, and the whole idea was to bring this back as much as possible. So I got on the internet, which is a great source of information and also misleading at times. So what I ended up with is, everybody says, well, you know, these motors, LV motors, LS and LT, share a lot of the same components. You can mix and match because they share so much. And according to the internet, the different drive systems that are available are the truck, the F-body Camaro, and the Corvette. Now, the Corvette has the shortest pulley on it, very tight up against the front, which is what I wanted. And that makes good sense. This motor, however, did not come in the Corvette. However, it is a derivative, so you'd think everything would fit. And according to the numbers, an LS damper for that is much shallower than this big deep guy, and gets it right up close. Dimensions say I clear my cross member. That's great. When I went to put this on, however, I discovered something. That's not all the information. This is from an LS and does not have a keyway in the damper. The original does, and the LTs do. So now I find out I need an LT damper. Well, the Corvette LT damper is another bunch of money, hard to find at times. However, ATI Dynamics makes one for that application. The nice thing too is it only has one set of grooves, the front set here, and not the narrower set on the back. That tucks it even further back, which is great. That would be nice. But now, the water pump I got, which was for the Corvette application, and did line up with this pulley, does not line up with that pulley. So I've got another problem. I've got to get another water pump assembly, which is on the way. And hopefully that will line up with this, because it's for a 6.2 Corvette. And so that is going to be the next step on that. Also, I'm going to have to remachine this mount for the power steering pump again and push it further back. Another something. But then I ran into another problem. When I installed this and used my installing tool and got all the way back, the crank wouldn't rotate anymore. It jammed up. So, well, why is that? It turns out that behind here there is a small lip on the oil pan up front here that hits the back of this damper. And when it's tight, it overlaps by about 40 thousandths, locking it up. My guess is that the Corvette does not have this little lip and definitely has a different oil pan, so therefore this lip isn't on it. That's the only thing interfering, and fortunately it is about 100 thousandths deep. I can remove a good 60-80 off of this without any problem, grind it off the front, and it won't interfere. And then everything should fit up again. So now the next thing is I have to grind this back and refit this to make sure it's going to go. Then of course there's the whole V-drive system, which I'll be getting to when it's in the car. I've got to get the sump pump for the dry sump system mounted over here with its own drive system. That's going to have to dog leg off of this. So these are the kinds of things that happen when you get into this sort of deal. And things don't always fit like you thought. You end up having to spend double, triple on parts before you find the right combination. Hopefully I can resell some of these other parts to somebody who's got a Corvette. Anyway, there you go. That's an example of the trouble you get into. So we'll get back to you shortly. Here is another one of those gotchas. It's better to think about now than find out later. So I've got the engine bay all painted up, welded up, coming back together, bolting everything in. And when I installed the steering components more permanently and got them tightened up, I noticed something.
I noticed that there's a flex in this shaft with load up here. So when the wheel is turned in, the outside wheel is loading and pushing in on this. If you hit a rock or a rut or something, which you will in rally, what's going to happen is you're going to be pushing in on this. As that happens, watch what I get. You see the flexing in that, if you can see that. What that is the force here, just by hand, is causing this to move up because the bearing is here. So it's pivoting like that. There is that 3-inch shaft extension on here, but it's got this big bolt. It's really solidly tight. So I'm flexing the shaft is what I'm doing. If I was to hit something out there and push really hard on this, this could move up. This would move up and in, and I would bend my steering shaft or break the housing. Either one wouldn't be too hard to do. So to prevent that, I've got to do something to brace this. So what I'm proposing to do is to put a shim up top up here that this will hit on if it moves up. So when it flexes in, if it tries to move up and pull this up, it's going to hit on this shim. And the idea there is it takes the load and transfers it from the bearing here to this big plate up here, which is great. And that'll take the load easily. So what I have to do is create a tapered shim. This moves uphill as this moves in and out. The travel on this is 5 inches. It's all the way in right now. So when it comes all the way out, it's 5 inches. And so I need a shim that's about 5.5 inches long that'll fit up in there and is tapered correctly. What I have is a piece of UHMW plastic. This is a wear-resistant material, ultra-high molecular weight polyethylene. It's used for wear material on sand and gravel, chutes, and all kinds of things. So as that's the case, this is a very good material. It's slippery. It's not going to rub on this all the time. It's not going to stay rubbing on it. There'll be a very slight clearance between this and this. But if it comes up, it's going to hit this. This will easily transfer all that load to the plate up here. It's wide enough that I can put bolts on the outside, not in the center where it's rubbing, and I can countersink them and bolt that through up here. The nuts will not get in the way of anything on the motor. So now I have to go ahead and cut this, measure the gap here and here, and machine this at a taper that fits that. And I'll only need about 15 thousandths between this and the rack, should be enough. That bit of flex it'll recover from in a impact. When it's extended, I'm not worried about it pulling down because the inside wheel turning outward would have to hit something to the inside to pull it down, and it's pretty unlikely compared to the crushing load you get on the outside wheel where the weight of the car is pushing in on it. So on the inside, not very much of a deal, very much less load because the tire has all the weight off of it for the most part on the inside. What I'm really worried about is this compression load coming in and bending this shaft on either side. So I'll have to repeat that for both sides, and hopefully that will be a safety factor to prevent this from getting damaged. Again, trying to think ahead. All right, plan B, which proves I'm not always the schmatty pants I'd like to think I am. Ran into a problem. So when I was measuring up here to where my UHMW wear strip was going to go, I failed to notice something. And that was that I was going to run it against this surface here, back and forth. Well, there's a boot here, and the boot sticks up past all that, which means I would just wipe the boot out right away. I could add another piece of metal up here, but there's precious little room as this gets narrower over here. So I said, that's really not a wonderful, lovely way to go. So I got to come up with another solution on that, okay? I had this all Loctited together for your pleasure. Well, I guess it all had to come back apart again. So now, I'll screw this back in here temporarily and show you what I am looking to do instead. So with this pretty much in place here, like that, here's what I got in mind. Instead of trying to put the wear plate up here, what I'd like to do is use a cam follower bearing. A little roller bearing, cam follower. It's got seals on it, won't get dirt in it, and attach it here. And it moves in and out this way, okay? I can put a piece of metal above here that it rides against that it can just follow straight in and out, and so any force will push it up into the plate. So that would allow me to have something that it can push against and thread that into the arm here. But if you'll notice, it's got a shoulder on it. So the problem is if I just thread it, I'm going to hit that shoulder and stop. And furthermore, I really don't want it to go that deep because then it will be too far back for the plate here. It'll be sitting too far back. The plate would be just in front of it. I need it out here a little where it needs to be with that shoulder. And I can't put a nut on the back because this is real thick and that's going to run out of thread. So the idea there is I've got to tighten it up and Loctite it in place, basically. However, to push it out, what I need is a little collar like that. So I whittled me out a little collar there that fits on it. That's also 1 inch just in case it gets onto that. I can thread that in until it stops against this with the Loctite, and that will put that guy in place. Now, the plate, I got a little fancy with that too. I figured, why not? So got me some 1/4 inch steel plate, and I milled me a slot in it for that roller. And it has a bottom on it, so it does have a little strength pulling down, but there's not much force on the pulling as much as on the pushing when you run into something with the front of the wheel. Pulling on the front of the wheel doesn't happen a lot, but it's a safety. This isn't a critical part of the steering system, it's a backup safety. So this is what I want to weld up in here. All I have to do is put my bearing on here. So I got to take this apart, drill and tap this, mount my bearing, come back with the plate, hold it here, move it in and out until it's smooth on here so I know I'm straight. Cut off the top, whatever amount I'm going to need, so I can get that cut off and then clamp it in place. Get it all straight and then weld it. You know, every time you think you're done and you paint things, yeah, gotta undo it. So fortunately, it's a rattle can part. I could repaint it. I didn't have to redo the red. But that's going to have to get welded to this guy here, and then that will sit in here and act as a guide plate for the roller. So that's the plan if it doesn't go to plan C. There you go, guys. I'll be right back. So that's what it looks like on one side. Moves back and forth. And I have all my travel. Now to repeat it on the other side. Man, I hate welding over my head. Anyway, a little more clean up, some paint, take it all back apart, put it all back together. You know the routine. So that's the reinforcement, okay? Just got to repeat it on the other side. It's almost time for these two to get married. And we're very close. But as Columbo said, there's always just one more thing. And in this case, that one more thing that still has to be put in place here is a thing called a pilot bearing. If you're not familiar with that, it's a bearing that fits in the back of the crankshaft that guides the snout, the input shaft of the transmission here, and keeps it nice and centered. And it doesn't need to be much of a bearing because the only time that they're spinning at different speeds is when you have the clutch disengaged and you're sitting at a stoplight, for example. That's the only time this is stopped and this is turning. So it doesn't take a beating, but there has to be one. And if you don't have a stick shift and you have an automatic, the torque converter sits in here, and the back of the torque converter has a hub on it that fits inside here and centers itself on that. Without that there, the pilot bearing needs to go there. And this is a GM pilot bearing. It fits right in the back like that. There's also one that goes deeper if you have a different style, but this is the one that's used on the LS and LTs. And that would be great, except for one little thing. That's not GM, that's Subaru. And she's kind of sloppy on there. That's not going to work. So my initial intent was to whittle one out of bronze, because in the old days that's how they made them. It was just a bronze bushing that went in here. As I said, it doesn't take much of a beating. And I got a chunk of bronze, and oh, this stuff's expensive and heavy. And I was going to whittle one out, put it in here. However, after thinking about it a little bit, I said, well, that's too big, not too small. So I should be able to make a bushing adapter that centers that up on there out of bronze, press fitted in here, and it'll still spin like it's supposed to on the bearing, but it will guide that and give me a little lubricity and center that up. Furthermore, there's another trick here. This doesn't stick far enough in here, and the reason is because of this big plate on here. It moves the transmission back, and in doing so, this whole input shaft only overlaps this bearing about a 1/4 inch, about half the bearing. And it doesn't feel very comfortable. So if I make a bushing that extends out with a larger OD diameter and goes into this and fits nice and tight, probably a press fit, I can make that whatever length I need. And the length I need is so that this shaft stub is almost fully engaged in that bushing. I don't want it tight up against the input shaft and preloading it, but I need to have it in here with just enough gap that it can cover most of that bushing area. And then this is press fit into the back like that. So if I can get those two things together, I think that it'll be time to get these two married. Did you bring the ring? Okay, a day later and a different shirt later, and I have my little bushing. So this is machined out of bronze. I've reamed it to 12 millimeters so it will fit nicely over this shaft here, real nice. And it's also been machined to 15 millimeter here, so it'll press into this bearing. So now the next thing to do is to press this together, put it in the back of the crankshaft, and then go ahead and stab the transmission on and look through the access hole where the clutch arm is so that I can see that I'm not bottoming out against this face or that I don't have a big gap, that everything is fitting about where it's supposed to. If that's true, then the next thing is to put the clutch together on here and finally marry this couple up. And then probably install the starter too to double check that before it all goes in the car. So that's coming up next. And there's my little bushing. So hope for the best. Well, I'll try to get you to see what I'm seeing there. As you can see, that bearing is not quite bottomed on the shaft and it's all the way engaged. And we are coupled together. This looks very good. Very happy. Now to take it all apart and put the clutch in. Well, as you can see, there's been a great leap forward. The engine and transmission have been buttoned up to each other. They're installed. They're bolted in. All the drive shafts are in. The shifter is in. The clutch is in and functions. You've got a heavy-duty clutch to handle the torque of this motor. And everything is in place and fits as planned. So this is a big leap. The engine bay has been painted. Everything is back installed with new suspension components and brakes. So this is a big move forward, and we're really glad to see it. So the next step now is to get onto all the accessory drives and things. So let me guide you through that a little bit. Well, the next thing I want to deal with is the serpentine drive system. As I mentioned earlier, the pulley that I had for the crankshaft was an LS Corvette, and it doesn't fit because it doesn't have a keyway. I ended up getting this ATI super damper that is for a 2016 Corvette with an LT. The change there is that it only has one set of grooves for one belt, not two. Most of the older ones had the power steering on one side and they had the air conditioning over here. And they ran the air conditioning off of the second set of grooves back here. Well, because this doesn't have that, it pushes it back a little more, which is great because now I get more clearance to my radiator, which I'm going to be using for another thing later. But the point here is that this really helps me out, pushing it back. The problem is that the water pump assembly I had for an LS Corvette now doesn't fit because the alignment of the pulleys is too far out, about a ½ inch too far forward. So I had to get another one of these. So this is from a 2016 Corvette. This is a LT water pump. And the alignment on it now does line up. So now my water pump and my alternator do line up, which is huge. That takes care of 2 of my 3 pulleys I have to manage. There is a little bit of an interference back down in here. Let me show you here. Pick this up. Right down in here, there's a bolt that's supposed to be there, and the head hits the back of this water pump. So what I'm going to have to do is put a button head fastener in there. That should take care of it. There's also a spot right between the castings where it just barely touches. So I'll go in there and grind off a little bit of that, maybe about 40 thousandths. Make sure I can pass a piece of paper down there. And once I can do that, then this is good to go. There is another problem, however, and that is now with the power steering. I want to put the power steering back where it was over here using the factory bracket that was on this engine. Now the Corvettes and many of the others, they use electric power steering, and so they don't have the pump on here. So putting the pump on is a whole nother issue. And to do that, putting that pump on, that's all great except that it hits right here. And right here, there is a temperature sensor screws in there. And it's right smack in the way. So I've got to move this temperature sensor. Fortunately, there's a lot of good room, like right over here. I can go up in here and drill this, and flatten it and give it a drill and retap it, and I can move this sensor up here out of the way. The bracket for this sits right here, like that, against the head. Now, there's a couple of interference problems underneath it that was holding it up too. Let me show you what I had to do with that. Put this back. Sorry for the jiggles. Okay, so right here this sticks up and the bracket here is flat on the bottom, and so it was hitting against this. So the first thing is I have to move that. I could drill a hole in this and put the sensor up in here, but it would hit the back of the pump. It really probably wouldn't clear. Easier just to move it. And then I'll plug that hole with a Allen plug as well as some Loctite and close that up, move the sensor. Now, to make room for this, there's also a piece sticking out here. On the old pump that I had, I can show you a little bit here, this right here sticks out and that hits it as well. So I could machine all of that off, but then I lose some of the room for my plug and don't really think I want to do that. So instead, what I did is I machined a pocket out on the back of this. There's plenty of meat, and I machined out two pockets. One for this and another one for this section right here it was hitting. So by getting rid of both of those and putting a pocket in there, it sits all the way down flat and my bolts line up. That's great. Now, I did have to shorten this quite a bit. This bracket right here was about 1.25 inches, 1.5 inches longer. Where the pulley stuck out much further, this pump stuck out much further. So because of that, I had to shorten it first for the LS pump and then again for the LT pump. So I've taken a lot off of this, but fortunately the pump is actually very narrow in there. It is a very narrow pump and fits down in there, and I still have room behind it where I'm not hitting against the head. So this is great. There's room back here, and that's a big help. Now, I could have gone to the Subaru power steering pump to match the rack, but it's easy enough to get fittings and hoses. I don't think I want to do that. I like this pump because these are very easily available. There's a lot of varieties. I can get them with AN fittings on them. They're a piece of cake, so I kind of want to stay with this pump. A hydraulic pump that produces the pressure and flow you want, that's all that really matters. As long as you have the pressure and flow, I don't care what it is. This, the pulley lines up, the bracket is nice and solid, fits the head. I don't have to machine out my own design of some kind of bracket. So I like that. So by doing that, I'll go ahead and plug this, put that in. I can put this on here, and then this lines up with the pulleys down here. So that helps me a great deal towards getting my serpentine worked out. So let me go ahead and bolt this on and set the pump back on and come right back. Okay, now to determine how much I had to remove off of this bracket, I used a straight edge across this pulley to this pulley, and measuring the distance from the front to the first groove on both of them, I was able to determine how much to remove. So that's how I determined that, a dial caliper and a straight edge. So the next thing now is to figure out how the belt's going to run. This is the old belt, not the one I'm going to use, but it helps me in laying this out and figuring out where things have to go. So we know one thing is on all of these motors, the water pump runs backwards from the alternator. So if the alternator turns clockwise, this has to turn counterclockwise. So the belt can come off this way, or it can come up here and go the other way. Most of these engines, what they do is they run the belt around the top here, around here, over that, down to your air conditioning and back. So that's kind of, they have just on this side of the motor. And that's the typical way. I got a pulley over here I got to deal with. And I don't have air conditioning, and I'm not going to. So I need to drive these three things off of the crank, and I need to make this go backwards. So if I was to come up here and come around here, I can't come back here because now I've got the belt rubbing on itself and I haven't taken care of this. So in looking at it, there's enough room between this pulley and this water inlet that I can go ahead and come right between there. And it's close. It's really close, but it works. So if I run it through there, backwards like that, and around my alternator, now I've got something. And I can come down to my damper and get it on here. And so now when it runs, you can see I've got something. Now I need to get over here. Well, I can do that, come around here, and the question is, do I clear here? Well, the fact is, if I pull it tight, I just barely touching the top of that. If I take off 50 thousandths right here, I can clear that. I mean, I could put an idler on it. I'd rather not, but it's really not going to be putting any pressure on that at all, but it's really close. So I'll have to deal with that a little bit. I'm going to have to just enough that it may vibrate and touch it, but I'm not worried about that. The next item is the tensioner. Normally these use a spring-loaded tensioner that pulls against the belt. And one of the things about a tensioner is you want to put it on the slack side of the belt. Most of these cars, you look at all these LTs and LSs, it's on this side, which means this is the slack side. On the tensioning side, if you put the tensioner on the tensioning side, when you rev it, it's going to pull on the tensioner, it's going to go loose over here, your belt's coming off. So you can't do that. You can put a solid tensioner that you can adjust over here, and that would be the first idea, would be to say, I just want to go ahead and run a tensioner that I can adjust with a screw, a bolt, and a slot, and pull it in here somewhere and suck it in, okay? That's one option, but I am putting a lot of load on that tensioner then, or on that idler and tensioner. And there's not a tremendous amount of room, plus I need to put my dry sump pump over here, so I'm not thrilled about that. I'd rather have the tensioner on this side. But there's a problem over here. If I do that, if I pull it out more wrap around here, I lose wrap down here on my lower damper. And I don't have a lot to begin with. So if I just run it like that, pull it around, and come up like this, I've only got that much wrap from here to here. If I pull it out for a tensioner, I lose part of the contact patch. And this is everything that's driving everything. And so I really don't want to lose any more contact patch off of here than I have to. Another idea would be to say, well, I could come with an idler in here and then a tensioner come out and make an S in it right here. That's okay, but it's pretty complicated, and that's one option. So the option I've got in mind, though, is a little bit simpler. If I go back to the old days where alternators were the tensioner, on the old GMs and everything, the alternator was on a bracket that pivoted on the bottom, had a slot up here, and it moved in and out like that. And I said, you know, that I could do probably. And I only have to make a tensioning device up here. So the idea there is to go ahead and pull up my slack over here. Now I know this belt is too long. Let me get around here. Like that. And then I'll take this bolt out. And there we go. And now if I pull that out, I can add tension to that. And the bracket will hold it nice and straight. When you tighten it, this doesn't clamp by bending the casting, because castings don't like to bend. So instead, get this up here a little bit. Hope you can see that. So instead, I'll make a billet piece that goes in between here. And when this pulls in right here, it actually has a bushing that pushes in against it and locks it. So I can make something billet that can move this in and out. So that is my plan for the moment, okay? And there was a time, you looked at earlier, I had planned to run an idler over here for the dry sump pump and do a belt reduction on that. Well, no more. As it turns out, now that I have this pulley back here further, I can get a drive pulley, a small drive pulley in here for a Gimler belt drive, and I can mount my dry sump pump right over here, driving directly off of it in this area, and I'm still not into my radiator. So that's really great. That's going to help a lot. So that's my plan, is to get this set up and then come back with that and bring my pump out over here on a bracket. I'll have to fabricate a bracket. Now all I got to do is measure the length of the belt. These belts, there's another interesting thing about these belts. So these belts generally are grooved on one side and flat on the other. Water pumps on your LS's, it's a smooth pulley, not a groove pulley. This is a groove pulley. What they did, for whatever reason, is they put grooves on both sides of the belt. So it's a dual-sided poly V belt. And there's not as many of those around, there's not as much selection in terms of what you can get in sizes. So I measured what I needed by simply running a measuring tape around where the belt goes right here, and where it overlapped up top, I got 70.5 inches for my drive length. And the measuring tape is the same width as the belt roughly, goes right on the grooves, and you just pull it around and measure. And so I know what I need, and I looked up online at the Gates rubber site for the dual-sided Poly V drives, and I can get something in about a 71.5. So I'm going to start there and get a belt for that, then I'll work on my tensioner. But you have to get the dual-sided or those grooves will eat up the back of this belt, and that's not going to work. The only downside to this is not having a spring-loaded tensioner means that it won't self-adjust. Modern cars, so much, they just self-adjust. I'm just going to have to do periodic maintenance and check the tension on the belt to make sure that if I have to move some more tension up here or not. So that's my plan in that regard. So that's where we are right now, and the next step is to wait for the belt to show up and start clearancing things and figure out my tensioner. That'll take care of that, and then I can get onto the power steering hoses and my oil pump drive. That's a big one. So we're getting progress, things are moving ahead, starting on the exhaust next. So this should end this chapter momentarily. You're seeing things starting to fit together, and it's exciting, things are coming together. So be back next time, probably working on the exhaust and the oil pump drive and all the hoses. So we're getting close to wiring time. Thanks again, catch you later.